So resolution of vectors into perpendicular components. Now it's been a week, so you'll have to remind me. What are vectors and what is resolution of vectors into perpendicular?
I think it's more than a week, sir.
Yeah, it's been more than a week, yes. It's week and a half. Okay, Anirudh, tell me, what do I mean by resolution of vectors into perpendicular components? This seems like a mouthful of thing to say, no? Resolution of vectors into perpendicular components. What does that mean? Yeah. So let me consider a vector. You understand what vectors are, right? So vectors are quantities that have direction and magnitude. This is what I've told you, right? And I've also told you about the way to add vectors. How do you add vectors? How do you add vectors, Rohit? If I give you two vectors, how would you add them? Suppose I give you that example. Suppose there is one vector over here. This is vector number 1. And then there is vector number 2 over here. So this is vector A and vector B. How would you add these two vectors? Forgot? Whenever you forget, just think of them as displacement. You are going from one place to another, from location O to location P, and from location P to location Q. What is the total displacement in that case? What is it as good as? You are going from O to P and then from P to Q. This is as good as going from
O to Q.
O to Q, that's it. So the way to add these two vectors is just draw a line, draw a vector from O to Q. So this we call as the result of A and B. A vector and B vector together result in A plus B. All right. I've shown you in the previous classes that forces also behave the same way, isn't it? If somebody pushes you like this and somebody else pushes you that way, you end up going in, you compromise for both of them, isn't it? Do not go in the line that first person is pushing you at, and do not go in the line that the second person is also pushing you at. You go somewhere in between. All right. So what does resolution of vectors into perpendicular component mean? Okay, it might sound like a big thing, it is not. All right. So all the scary looking terms in mathematics, they are really innocent. Okay. So here we have a vector. Let's see. This is vector A. Now I've told you, you can add two vectors, isn't it? This is what I usually say when I have numbers. Like this is what you do in algebra. You write 5 as 3 plus 2. Now if I ask you, why did you write 5 as 3 plus 2? My wish. I see 5 as 3 plus 2. All right. Or why not 3 plus, 4 plus 1? Yeah, it is also 4 plus 1. As long as we are talking about the same thing, we are okay. So you wrote 5 as 3 plus 2. And here also I'm going to do the same thing. You give me a vector A, I'm going to write it as this vector over here plus this vector. Oh, sorry, I made a mistake. Yes. But these vectors that I've drawn over here have to be perpendicular. One second, let me change that. Yes. Do you realize what I'm doing? I'm writing a single vector as sum of two vectors. So I have a vector over there. I write it as x vector plus y vector. Do you understand, Rohit?
Like
what I'm
Pythagoras theorem.
Not really. Pythagoras theorem is something to do with numbers, isn't it? Or areas. This is about directions. Look at that. I'm saying, okay, Rachit went from, let's say, Rachit went from O to P. Let's say that. Okay. I am saying Rachit went so many kilometers to the west and then so many kilometers to the north to reach P. The result is the same, isn't it? If you go x kilometers to the east and y kilometers to the north, it is as good as reaching the point P. So instead of saying Rachit is going from O to P, I'm saying Rachit is going from O to some point, let's say Q, and from Q to P. But the path of Rachit, that a rectangular component, sorry, resolution of vectors into perpendicular components. Perpendicular because I could write it any way I want, and we have done this exercise in the previous class. We have tried to write the vector A in terms of weird looking vectors like this. I can write OP the same vector as like that, isn't it? Look at this. Just try to trace it. You go like this and like that. It's as good as reaching the same point, isn't it? So you can resolve a vector. Resolve means writing in terms of other vectors. You can do that in many ways possible. Any way you can do it. But perpendicular components means we are looking only for the we are looking for only those vectors which form a right angle triangle with the given vector. Okay, now you might think, why is this special? Why is 90 degrees special? Because I told you that you could do it any way you wanted. See, this is also a resolution of vector. This vector, one vector, plus the two vector, I'm just giving names, I could call it R vector or bar vector or anything. So if you see from the triangular law of vector addition, see, going like this and like that, you end up at the point P. So you can write A vector to be equal to 1 plus 2 vector. You could do that, isn't it? But that won't be a rectangular resolution. That won't be a rectangular resolution. Now, why am I insistent that there is this rectangular resolution of vectors is important? You will see in a moment. Yes, Sandra.
It makes calculations much more easier.
Makes calculations much more easier. Not just that. It has something to do with nature itself, the way nature behaves. Okay. Now, it seems like it makes calculations easier. But if the nature was any other way, we would have to follow what nature is doing, isn't it? Just to make your calculations easier, okay, now you can't tell a story differently just to make a story easy, right? The story has to be told. The story of the nature has to be told. And luckily for us, nature resolves vectors in perpendicular components. All right? Luckily for us. Otherwise, I'd have to teach you more mathematics than this. If I'm not wrong, we were doing this problem. And this was supposed to be Avani's problem. If it wasn't, now it is. You have to tell us the answer, Avani.
Sir, I haven't solved it.
I know. I know. Solve it now. Where is my friend Yashwardhan, always hiding?
No, sir.
No? Okay. So, hiker, you can see the screen clearly, right? A hiker begins a trip by first walking 25 kilometers southeast from a car. She stops and sets up her tent for the night. On the second day, she walks 40 kilometers in the direction 60 degrees north of east, at which point she discovers a forest ranger's tower. Determine the component of hiker's displacement for each day. Do that part. Yes.
I have a doubt.
Okay. Yeah, tell me, Tripti.
So when we show the components of a vector, do we write it in the form of I comma j, I cap comma j cap,
I cap and J cap. You may.
or
You
x
may
and
do that.
y?
You may do that actually. You can say X component is so much, Y component is so much. Or you can say the displacement of the hiker, displacement vector is equal to X component I cap plus Y component J cap. You could do both ways. Right?
Yes, sir. Thank you, sir.
Yeah. Nihal, can you help me out? Determine the component of the hiker's displacement for the first day. First day, let's do that. So first day, what does she do, Nihal?
First day, she walked 25 kilometers.
25 kilometer, which direction? That is also important, right?
Southeast direction.
Southeast means what?
45 degrees, like.
Southeast, yeah. Exactly between south and east, right? Exactly between south and east. So let's put the initial position of the hiker there. This is where she is. And let's look at the compass here. Compass says that's north. Actually, it could have said anything is north. Don't think that this has to be north. This also could be north. Who knows where the hiker is, right? But for simplicity's sake, I always keep north to be like that. And let's say this is the east. So this is north. So hiker goes 25 kilometers southeast from her car. So she's going. So let me draw a line over here. This line would represent the south direction. So here's that line. And here's the line that represents the north direction. Are they perpendicular? Let's hope so. Yes. Oh no. Okay. Now northeast means you go exactly in between, 45 degrees. Okay, 45 degrees. Is this 45 degrees? Yes. You go exactly in between. And how long does she? I mean, what's the total distance that she has walked? She has walked a distance of
25 kilometers.
Sorry.
40 kilometers.
40 kilometers? No, on the
25.
25 kilometer. Hiker begins the trip by first walking 25 kilometer from the southeast from her car. So she's walked 25 kilometers. Now, Nihal, what can you say about the X component and the Y component, or rather east component and the south component? If you walk exactly in between the two directions, what can you say about east and west, east and south component? Which direction do you walk more? If you walk exactly 45 degrees, do you walk eastward more or southward more? Yes, Nihal? Yeah, Sarvesh, which way do you walk more? South?
Sir, they go in equal direct, like they'll not neither go more in east, like not in south also, like they'll be in middle.
Yeah, that should be equal, isn't it? So you should walk equal distances along the south. So this is the distance walked along the south, this line over here. And this is the distance that is walked along the east. And Sarvesh tells me that it's both equal. All right, do you agree?
Sir, I had put up an answer in the.
You have put up an answer.
Even I have put up, sir.
I can see Tripti's answer. Yeah, Tripti, your answer looks correct. But I have not received your answer, Sandra. Vint, new message, Vint. Yes. Okay, now how to find that distance, Sarvesh? How to find the distance walked along the east, and how to find the distance that is walked along the west, along the south. So this
Sir,
angle is 45 degrees. Yes, yes, Sarvesh.
Like the distance between east and south, like that'll be 90 degrees. So from there, we can find the.
Yeah, this is 90 degrees you're saying, right? Yeah. So these two distances are equal. That's what you said, correct? Because that angle is 45 degrees. And moreover, you can see that it would be an isosceles triangle, isn't it? So you can figure it out. Now, What can you say? We want to find the east distance and north distance. How do we do that? Can we use trigonometry a little bit? What does trigonometry say? If you have 45 degrees, if you've got 45 degrees over there, what does trigonometry say? Trigonometry is just a shortcut for you. All right. So let's take a ratio. Let's take the ratio sine 45. Sine 45 means what? Where is the 45 degrees? Here's the 45 degrees. Sine of 45 degrees is what?
1 by root 2.
1 by root 2. But also, what is sine of 45? Opposite by?
Hypotenuse.
Opposite by hypotenuse. Opposite is nothing but this distance. So let's call that distance as d. So d divided by hypotenuse. What is the hypotenuse here? 25. The length of the hypotenuse. What I don't mean when I say what is the hypotenuse, I mean the length of the hypotenuse is 25. So this would give me the d. D value is what I need to know, isn't it? The southward component. Agree, Aishwarya? Yeah. So d will come out to be 25 divided by root 2. 25 divided by root 2. So d is nothing but the south component. South component came out to be 25 by root 2. Now what is the east component? East component is also 25 by root 2. Okay. Now you are not under pressure to convert it to decimals. Don't try to convert it to decimals. It's okay if you have done it, but not really required. As long as you understand, okay, what has happened there, 25 by root 2 is a perfect answer. Right? So on the first day, we can write the displacement of the hiker on the first day. Let me write that. D1, displacement on day 1 is equal to 25 by root 2 I cap minus 25 by root 2 j cap. Yes.
Sir?
Yes, Aishwarya.
Sir, can you say again how it came root 2? And
This 1 by root 2 is it? See, sine of 45 is 1 by root 2 is what I said in the previous class, isn't it? Now, how did it come? How do we know that it's 1 by root 2? See, when I'm talking about trigonometric ratios, okay, when I say trigonometric ratios, I'm talking about all right angle triangles, okay? Now, you can take any right angle triangle that you want. Let's say I take a small one. A small triangle, small right angle triangle, sorry. Okay, you can see that I've tried to draw it small, right? But this triangle is special. This triangle is special because one of the angles is 45 degrees. All right. Now, if it's 45 degrees, Aishwarya, what can you say about this particular triangle? What are the other angles? One is 90 degrees. It's a right angle triangle. I have no choice there. If one of the angles is 45 degrees, what is the other angle? In a right angle triangle?
same.
Same, yes. 45 degrees, isn't it? You're right. So we have what kind of a triangle is this? If you have 45 degrees and 45 degrees, two angles are equal. What do you call such triangles? There's a nice property, no? That if two angles are equal, the opposite sides to those equal angles will also be equal, isn't it? We call such triangles as isosceles triangles. All right. So these two angles are equal. Now, I do not know what this length is. So let me call it as A units. Or shall I call it as 1? So what can I? Or can I not? Will there be any problem if I call it as 1 instead of A? Okay, let's say you measure the length. Yes. Sorry? Let's say you can call it 1 or can't. I did not hear you. You can call it 1. 1 means what? 1 is infinite. 1 is some unit, isn't it? So suppose you measured that length over there and it came out to be 2 inches. So I'm saying, okay, let's define a new system of units where 2 inches is 1 unit. All right, you can do that, isn't it? I've told you measurement is based on the standard. So if it came out to be 2 inches, then you call it as 1 unit. Okay, whatever it comes out to be, you call it as 1 unit. So I don't really have to call it as a unit. So let me call it as 1. Okay. Now, what does the Pythagoras theorem say? I want to figure out the hypotenuse now. Can I find the hypotenuse if I know 2 sides? I can figure out the hypotenuse if I know the 2 sides, isn't it? Let's name this triangle. So ABC. So hypotenuse is AB squared is equal to AC squared, which is 1 squared. Let me write that later, plus BC squared. So this will come out to be 1 squared plus 1 squared. This is my AB squared. So AB square comes out to be equal to 2 and AB comes out to be equal to square root of 2. Square root of 2 what? Units, whatever these units are. Okay, if I taken A units, I would have got root 2A. Okay, that would be the difference. All right, but I've got root 2E here. Okay, now I can use this information for any other problem. So suppose I'm given a bigger triangle. It's a right angle triangle, but a bigger one. But the specialty about this big triangle, PQR, is that one of the angles is 45 degrees. Okay. Can I say that in this big triangle, one of the angles is 45 degrees means that these two sides are equal, isn't it? Now let's say that this is some 10. That is some 10. What would be the hypotenuse? Can you tell me? What would be the hypotenuse? When it was 1, it was root 2. What would be the hypotenuse when it is 10?
10 root 2.
Yeah, 10 times root 2. 10 times root 2. You see what is happening over here? These two triangles are what are called similar triangles, isn't it? Similar triangles. So in similar triangles, what do you know? What do you know about similar triangles?
The ratios of the corresponding sides will be equal.
The ratios of the corresponding sides will be equal. What does that mean? So if you've got a smaller triangle over here, how do you get the big triangle? You have to zoom that, isn't it? You zoom that, all the sides you zoom properly, so that triangle becomes bigger there. Look at that. You zoom every side in the same proportion. You don't zoom one side to be at some ratio and another side in some other ratio. You zoom all of them at the same extent. So what will happen? So you get the other triangle, isn't it? So if the corresponding side, look at this. If BC you have zoomed by 10, you zoom AC also by 10. And automatically you have to zoom the hypotenuse also by 10. Right? So 10 root 2. So this trigonometry is what? Ratios of the sides. Isn't it? Sine 45 means what? Sine of the opposite side. Sorry, sine of theta means opposite side divided by the hypotenuse, isn't it? But the interesting thing is, no matter which triangle you talk about, if the angle is 45 degrees, if the angle is 45 degrees, opposite side is zoomed by some amount and the hypotenuse is also zoomed by the same amount, isn't it? So if you talk about one triangle, you can talk about every other triangle out there. Because if 45 degree, if you take the 45 degree angle, the triangle, that is basically either it is zoomed out or it is zoomed in version of the same triangle that we spoke of, isn't it? So anywhere you find a triangle, a right angle triangle, which has an angle of 45 degrees in it, then you can apply the trigonometric ratios and say, okay, sine of 45 in that triangle was 1 by root 2. In this triangle also, it must be 1 by root 2. all right, because sides are zoomed in or zoomed out in the same fashion. Okay, that's the idea of trigonometry. Okay, it's like a shortcut. You don't have to again and again apply Pythagorean theorem and all those things. It's a shortcut. You remember that. So sine of 45 is 1 by root 2, because in this triangle you can see, when I say in this triangle, I mean this triangle over here, sine 45. So 45 degrees is over here. This is 45 degrees. So sine 45 is defined as what, Aishwarya? Opposite side to the hypotenuse, isn't it? Opposite side to 45 degrees. So here's 45 degrees. Opposite to that side is this one. Right? Opposite side, which is 1, divided by the length of the hypotenuse, which has come out to be root 2. And you can see in this triangle also, if I take this to be the 45 degree angle, again sine 45 is opposite side, which is 10, divided by the adjacent, the hypotenuse, which is 10 root 2. So if you take the ratio 10 by 10 root 2, it will again come out to be 1 by root 2. Okay. So trigonometry is a glorified shortcut. Okay.
Excuse me, sir.
Yes.
So, what is I cap and J cap?
You've been missing for quite some classes, no? Yes, Rachit.
Yes, sir. I was missing full December.
Full December. Rachit, I'll help you out with that, okay? But right now, to deviate from whatever I'm doing won't be fair to everybody else. But it's not as complicated as you think.
Yes, sir.
As and when the problems come, I'll help you out.
Yes, sir.
Okay. So we have solved only one part of it, isn't it? Okay. Yes. Rachit. So here you see, I've written D1 vector, displacement of the first day, as 25 by root 2 I cap and minus 25 by root 2 J cap. Right? So I cap is a vector in the east direction, you can say, or actually it is in the x direction. All right, I cap is a vector, unit vector. Unit vector, you understand, right? So it's got a length of 1. All right. So 25 by root 2 I cap, that's one magnitude vector. But I have to multiply by 25 by root 2 to get a proper full length vector. See this vector. To get that vector over there, let me write that in yellow. I need to multiply by number 25 by root 2. That's around 17, I guess. So 17 times I cap, that see I cap is this vector. When I multiply by a certain number, its size is bigger. Okay, so it will represent this particular arrow over here. Minus 25 by root 2 J. So J vector is, J cap is a vector that is pointing in the Y direction. We have defined these like that. Okay.
Yes,
so what is minus J? Minus J would be in the opposite direction. So I got the direction now. What is the length of the vector? Length of the vector is negative 25 by root 2. Sorry, not negative 25. 25 by root 2 in the negative direction. So you'll get this vector over here. Now look at this. Let me write it differently for you. So 25 by root 2 I cap plus 25 by root 2 negative J cap. Is that okay, Rachit? Negative J cap,
Yes,
you understand? Now, if you add them vectorially, this is vector addition because this is a vector and this is a vector. What do you get? You get the displacement. Look at that. You get this vector. The displacement of the hiker. Okay, so I've written it as sum of displacement along the east direction and south direction. Vector sum. Is that okay?
Yes, sir. Got it, sir. Yes, sir.
Yeah, go to find the displacement of the range of hiker in the on the second day. On the second day, let me draw again what happened on the first day. So hiker was over there, then she went 25 kilometers southeast. Now she is over here. Here's a tent. And what does she do now? Yes, Tripti, what does she do?
She walks 40 kilometer in a direction 60 degrees north of east.
North of east. What does that mean?
From east, 60 degrees
Towards north.
towards the north.
Towards the north. So take your compass, measure 60 degrees from the east direction, isn't it? Measure 60 degrees from the east direction, but towards north. You have two options of measuring the 60-degree angle. One is to go this way, one is to go that way, and the other one is to measure it like this. Sorry. Right? There are two options there to measure the 60-degree angle. So since they're saying 60 degrees north of east, you choose the first option. You go north from the east direction. So we go this way. So we are going like this. And how long does she need to walk for?
40 kilometers.
40 kilometers. Okay. So she walks 40 kilometers north of east at an angle. Yeah. Now find out the components of the hikers. Determine the components of hikers displacement for second day. For second day. So we have determined the components for the first day. Let me just write them down. So for the first day we had (25 by root 2) and 25 by root 2. Yeah. First day is done. For the second day. Aishwarya, can you help me out here? Don't worry if you can fully get the answer. I'll help you out. Sorry?
I don't know, sir.
Don't say you don't know. I know you know something. Okay. Just I just want you to get that out. Okay. Whatever you know. I'm not going to yell at you. Don't worry. Okay. Yes. North and okay, so you can see that the hiker is going towards the north a little bit, isn't it? She's walking towards the north, right? So there is a north component and then there is a east component. See, she's going in an angle like that, isn't it? So she's walking towards the east as well as walking towards the north. Okay, we have to figure out how much she has walked eastward from here. Look, if she's originally over here, this is where she is right now. This is where she is going to end up. I want you to tell me how much towards the east she has gone and how much towards the north she has gone. Is that okay? Do you understand that statement there?
Yes, sir.
She has gone towards the right, isn't it? She's gone towards the right a little bit, that right meaning eastward, and she has gone towards the north direction as well. So I want you to tell me how much. So what do you recommend here? Because right now all I have got a 40-kilometer line there, right? To figure out how much to the east and how much to the north, what do you recommend? What kind of do you recommend any sort of constructions? Can we boil this problem down to something familiar?
She went 40 kilometers, sir.
She went 40 kilometers from this point to this point. This is 40 kilometers. It's a long distance, by the way. I don't know why people go hiking. What is the point of this? But anyway, she has walked. We got to do
It's
this.
adventurous.
Sorry? Why is adventure required?
It's adventurous and fun
Okay, fun is
for the pleasure of mind.
okay. Watch a movie next time. Yes. Yes, Aishwarya. So what do you recommend any sort of construction to be made over here? Can you boil it down to a familiar problem? That's what I'm saying. You've solved certain kind of problems, no? Some familiar kind of problems. What is that? Okay, I'll do that. But can you tell me what to do next? So see, here's the north component, isn't it? See, this is the north component. I drew a perpendicular drawn from there, isn't it? Now what did I get? I get the north component. The length of this arrow, the length of that perpendicular is the north component, isn't it? That's how much she has walked up, correct? Not up exactly, towards the north. And this is how much she has walked towards the east. See? You understand that, Aishwarya?
Sir.
Yeah. Now I have to find the
Sir.
length. Yes.
I have a question. That time she went southeast, right? So
Yes.
it goes down. You've written it towards the left, right?
Yeah. So she was originally over here. I'm just doing the second day part. I'm just trying to find the components for the second day's displacement, not the total displacement.
So the total displacement comes out later.
Yeah, that would come out later. I'll do, if you want the total displacement, I'll write it over here. So
we'll just finish this one.
yeah, let me just write it down. So total displacement is, this is the displacement number 1 and this is the displacement number 2. So she went down first, she went a little bit down and then she climbed, she went northwards. Now she has ended up over here. So the total displacement is represented by that arrow. Is that okay? That's it? Yes.
Yes, sir.
Now we are just trying to find out day 2's displacement. Okay. So I see a 60-degree angle over there. And I know the hypotenuse in this particular triangle, this triangle, right angle triangle. So I want to find the opposite side and the adjacent side. Avani, can you help me out? How do you find the adjacent side and the opposite side there?
Opposite side by sine 60 and adjacent side by cos 60.
Yes, correct. I can use the trigonometry ratios. So I have done for a certain triangle. I've figured out these ratios for certain triangle. Now every time I see some triangle which is 60 and 30 and 90, I can say that this new triangle is similar to the old triangle for which I figured out the trigonometry ratios, isn't it? Ratios don't change, so fine. Let's go ahead. So sine 60, I know, is opposite side divided by the hypotenuse. Opposite side by hypotenuse. I want to figure out the opposite side. Opposite side means the north displacement. So hypotenuse I know. Okay. So this is what Avni had told me. So opposite side is equal to sine 60 into the hypotenuse. Not divided by hypotenuse, Avni. Okay. Multiplied by hypotenuse. So sine 60 is how much? How much is sine 60? Rachit, do you know the value of sine 60?
Not really.
Okay, so let's
root 3 by 2.
Root 3 by 2.
Root 3 by 2, right? Okay. So root 3 by 2 into the hypotenuse. Hypotenuse is 40. So Sandra, how did we figure out that value root 3 by 2?
Sir, if you take like a mirror image of the triangle, the 90-60 triangle, 90-60-30 triangle.
Yeah, correct. So
you will get an equilateral triangle.
yes. So good. What we take, let's say that we take an equilateral triangle. Let me do it another way now. I mean, it's the same thing. Okay. Oh my God. I'm taking an equilateral triangle of side 1. I'm taking an equilateral triangle of side 1. So this will be 1 by 2 and this will be 1 by 2. Okay. What would be the height of this equilateral triangle then? That you would find by
3 by 2.
that you would find by applying the Pythagorean theorem, isn't it? So root 3 by 2. Why? Root 3 by 2 square. What is root 3 by 2 square?
3 by 4.
3
3
by
by
4
4.
plus 1 by 2 the whole square. What is that?
1 by 4.
1 by 4. 3 by 4 plus 1 by 4 would be 1.
1.
That's the hypotenuse, isn't it? So it works out. Okay. So height is 3 by 2. Height is 3 by 2. All right. Now, what is this angle here? Array, why am I doing this? What is this angle over here?
60
Rachit,
degree.
one second. Rachit, what is that angle there?
Where's 90 degree?
This angle over here.
Oh, sorry, there 60 degree.
60 degrees. And here it would be 30 degrees.
30 degrees.
Okay. Now can you tell me sine of 60 degrees? Sine of 60 means opposite side opposite to the 60 degrees divided by the hypotenuse. So sine 60 means look to the opposite of 60 degrees, whatever the length is, divided by the hypotenuse. Yes, Rachel?
Sir, sine
Yeah.
60 degrees root 3 by 2 into, wait, root 3 by 2 into 40, right?
Why 40? Where do you get 40? Oh,
Right
no,
side, you.
I'm not talking about that triangle. I'm talking about this triangle over here. Sine theta, look at this. Sine theta is defined as opposite divided by hypotenuse. Always, whichever triangle you look at, sine theta is defined as opposite by hypotenuse. Here I'm asking what is on the opposite side. Okay, the side length on the opposite side is root 3 by 2. Divide that length by 1. 1 is what? Hypotenuse. Is that okay?
Yes.
Yeah, you'll get familiar with this. That's it. Don't worry. Okay. So in this triangle, in this 1, 1, 1 triangle, we found that sine 60 is root 3 by 2. That is not completely useless. If you figure out for one triangle, we can figure out for every triangle because of similarity of triangles. All right. So this triangle that you see over here in the particular problem that I'm solving, that triangle is it's not got 1 kilometer as the hypotenuse. Here we have 1 kilometer as the hypotenuse, isn't it? So it has not got 1 kilometer as the hypotenuse. It has got 40 kilometer of the hypotenuse, isn't it? So what should be its height? Can you tell me what should the height of this triangle be? Hypotenuse is multiplied by 40, isn't it? So height also should be multiplied by what? If hypotenuse in this particular triangle is multiplied by 40, height also must be multiplied by 40, right? So here the height is root 3 by 2. Here the height would be root 3 by 4, root 3 by 2 into 40. Isn't this what you said over here? Look at that. Sine theta is equal to opposite by hypotenuse, and opposite is equal to sine theta into hypotenuse. That's what you said, right? See, that's what I'm saying here also. Can you tell me what this length would be? Can you guess? In my 1, 1 triangle, that length was half. In the zoomed out triangle, what would this length be? Everything you have to
20.
multiply. Yes, everything you have to multiply by 40. So multiply half also by 40. Done. Simple, isn't it? That's what trigonometry is. Okay, now day 2 displacement. Day 2 displacement. Can you tell me, Rachit? Okay, Rachit, I'll be bothering you for the entire class today.
Oh God.
Yes. Oh God is the correct response to that. Yes. What is D2? D2 in the vector form. Here I had written D1. D1 as 25 by root 2 I cap minus 25 by root 2 j cap. Can you write it in the similar unit vector notation what it would be?
Root 3 by 2?
No. It is half of what? That is 20 I cap. See, 20 I cap. You are going 20 steps along the east direction plus,
20 I cap.
yeah, 20 I cap and plus root 3 20, 20 root 3 j cap. Why 20 root 3? I've just cancelled this off. So 20 root 3 j cap. Is that okay?
Yes.
Yes. Now determine the second B part of this question. B part of this question. Determine the components of the hiker's resultant displacement for the trip. This resultant displacement they have called as R. You can see here. Find an expression for R in terms of unit vectors. So what is R? You have written down D1 and D2. Displacements 1 and displacement 2. The problem might seem a little bit hard, but if you open your eyes completely, you'll see the answer, the right thing. Nidhishri, can you help me out here? What is the total displacement? What is? You tell me how much she has walked along the east direction. What is the total distance walked along the east direction?
25 by root 2 plus 20.
25 by root 2 plus 20.
20 I, sir, won't we use I cap here?
Sorry?
So, won't I cap be used here?
Yeah, it will be used. It will be used. So I'm just asking what is the total distance walked there, right? I did not ask the vector notation. So you can see we started over here. The hiker started there. So on the day one, she walked this much along the east direction, isn't it? On day two, she started over here and she walked this much on day two towards the east, right? So the total that she has walked, look at that, you can see it right here. If this is the resultant vector, you can see that the total distance that she has walked, total displacement along the east direction is the total displacement on the first day, total displacement along the east on the first day, plus the total displacement along the east on the second day. Okay. And I've told you, moreover, how to add vectors, isn't it? What do I mean by adding vectors? D1 vector is given as 25 by root 2 I cap minus 25 by root 2 j cap. And D2 vector is 20 I cap plus 20 root 3 j cap. So when you are adding D1 plus D2, the sum of two vectors, you add component wise, isn't it? So add the x component to x component. What is it? 20 plus 25 by root 2 I cap. So this is root 2 I cap plus. What about the next one then? What do we do in the next case?
Minus 25 by 2 plus 20 root 3 j cap.
Yeah. In the second day, on the first day, she went southwards. How much? 25 by root 2. That much, isn't it? And on the next day, she came up, she went northwards. A total distance of how much?
20 root 3.
20 root 3. So what is the total that distance that she has walked northwards? She has walked a total distance of how much? 20 root 3 minus 25 by root 2 j cap, isn't it? So let's write that. So plus 20 root 3 minus 25 by root 2 j cap. So that's the unit vector notation. Simple, right? No, Sarvesh?
Both, sir.
Okay.
Sir,
Yes, Vinay.
sir, to Sandra and someone typed the answer how much time ago, sir?
Why?
Sir, was it correct?
Yes.
Okay, sir. Okay.
Sandra had given the answer 20 minutes before me. But that should not be your concern at all. Shiniket.
Sir, I had already like looked about trigonometric ratios before,
See,
so this one comes out easy for me.
Thank you for your honesty, Sandra. And also Tripti, I'm sure.
So I had solved it long back. The day which you told us to solve it, I had solved it that day itself.
Thank you both for your honesty, because otherwise it seems like they have solved it 20 minutes before and now I can't solve it. That kind of thing creeps in.
No,
Right?
because before everything, like even during the lockdown
Yeah, super
itself,
smart.
it was something that I just did it.
Sir, this
So-
makes our IQ down, so.
Oh no, it's very simple. I had a lot of time practicing this. That's all.
Yes. So that's the thing. She has practiced, and when I asked the trigonometry ratios, only a few of you knew. That's usually the case. In high school, you don't tend to remember these ratios at
Okay,
all.
so the
Yes, Rachit.
So the final answer is this itself, right? 20 plus 25 by root 2 I cap plus 20 by root 3 minus 25 by 20 by root 2.
A cap, yes.
20 by root
That's
2.
what that asked us, no?
Root-
Find an expression
oh,
for
God.
in terms of unit vector.
Okay, so the final answer is that much. There's no
Yes.
simplification after that.
No. That's it.
Okay, sir.
By simplification, you mean do you mean write it in the decimal form? You could do that, but I don't see the point of it.
I would not figure that out anyways. So never mind.
Okay. All right. So consider the displacement vectors 3i plus 3j. P is equal to I minus 4j and C is equal to minus 2i plus 5j. Use the component method to determine the magnitude and the direction of A plus B plus C. What is A plus B plus C? We have to add up the three vectors there, isn't it? 3i plus 3j, 3i plus 3j, that is A vector, add that to B vector, which is I minus 4j, and ultimately to C vector, which is 2i plus 5j. Where is Neha? Neha, what does the vector A look like? 3i plus 3j. What does it look like? How many steps to the right do we have to walk there?
3 steps to the right and 3 steps.
Yeah, 3 up, right? 3 steps to the right. Let's write that down. Let's say this is 3 steps, and 3 steps up. And the resulting vector is A vector. So this is 3 steps to the right and 3 steps upward. Add the two. Add means you are vectorially adding according to triangular law, and you get the A vector. Okay, once you have reached there, we have to have a B vector. What is B vector? I minus 4j. So let me do that in yellow. So from this point, we have to add the B vector. What is B vector?
1 step to the right
One step to the right
and 4 steps down.
4 steps down. So yes, 4 steps down. So this is 1i and 4j. Yes. So this vector, now add them. How to add? Just join the two endpoints. So this vector over here is the B vector. I hope it's not getting clumsy there. Yes. Now C vector, what is C vector? Minus 2i plus 5j. So you come back by 2 steps So this is minus 2i. This is minus 2i, and climb up by 5 steps. Okay, so if you climb up by 5 steps, this is already 4 steps down, so you'll have to rise up by 1 step ultimately. Yes. And this green vector over here, now it's clumsy, very clumsy, I realize that. It's very, very clumsy, but let's see, 5j. So this vector, green vector over here would be the C vector. Now what is the resultant of all this? What is the resultant of all this? The resultant of all this is, okay, you figure out where you started. Yes?
Vector D.
Yeah, vector D, what is vector D? Vector D is A plus B plus C.
A plus B plus C.
So you add a vector, so look at this, a vector, let me do it in a thicker point. So this is the a vector. To that you add the b vector, see here's the b vector. And to the b vector, you add c vector. So ultimately, where would you end up? You would end up here. So this is your d vector. Alright.
So we got the direction.
No, direction not yet. This is just me trying to draw it out for you. All right. Direction means what? If I just say, okay, this is d vector, would you be satisfied? I'd have to tell, okay, how many, what angle does it make with the horizontal answer? Such things. All right. Now, I do not really have to do it like that. I can just keep track of. X motions along the x direction. So in the first vector, you're walking 3 steps to the right, isn't it? You're walking 3 steps to the right. In the second vector, you're walking 1 more step to the right. But in the third vector, you're coming 2 steps back. I think you saw that even in my back diagram. We're going up like that, then we walked forward a little bit, and we came down, and then we walked back, isn't it? So we walked 3 steps forward plus
So
1 step forward. Yes, that's it.
The M over there is magnitude, right?
M over here is meter.
Meter, okay.
Yeah, meter. They're telling you what units are these. So 3 steps means what? What is each step? Each step is a meter. That's what it means. Okay, thank you for asking that, because I'm not specified that. Each step is a meter. Each step is 1 meter long. All right. So 3 steps to the right plus 1 step. So what is d vector? D vector is basically how many steps to the right? That is 3 plus 1, 4. 4 minus 2. That is total of 2 steps to the right. And then we have 3j minus 4j. Okay, we went up by 3 steps and came down by 4 steps. So we are, and then we climb up by 5 steps again. So that is 3 minus 4, that is negative 1. Negative 1 plus 5, that is positive 4. So 2i plus 4j. 2i plus 4j. Let me just plot it out for you. 2i. So 2i plus 4j. So 4j would be like this. Yes, this is my d vector. What is its direction? Now, who will answer that? 2i plus 4j. What is its direction? By direction, I mean, what angle does it make with the horizontal?
So what about the magnitude?
A magnitude we can find. Okay, magnitude is not a hard thing. So I know that this is 2 steps to the right and 4 steps up. Can you think of the magnitude now?
Using Pythagoras theorem.
Exactly. Use the Pythagoras theorem. So the magnitude of d vector, the size of d vector, is the size of the hypotenuse of the 2, 4, whatever triangle. Right? So that is 2 square plus 4 square. But this has to be put under the square root. So this will come out to be root of 20. 20 what? Meter. Root of 20 meter, because all of these steps are taken in meters. root 20 meters. But what is this angle over here? That's what we want to find out. What is its direction? We know its size, but what is the direction? How do you do that?
So we can use tan theta.
Oh, very good. We can use tan theta. Tan theta is what? Tan theta is
Opposite
Opposite
by
by
adjacent.
opposite by adjacent, so 4 by 2, and this comes out to be 2. Tan of this angle theta is equal to 2. This doesn't mean much actually. Tan theta is equal to 2. So what? So we have to look for we are basically looking for a triangle. Okay, we are looking for a triangle in which the opposite side is twice as bigger than the adjacent side. So you can do this. Try this out. Okay, try this out. Draw a right angle triangle in which the opposite side is twice as big as the adjacent side. Find the angle. Use a protractor and find the angle. Okay, draw any triangle. I'm saying I don't have to draw 4 and 2. You don't have to draw 4 and 2. You can draw any right angle triangle you want with the opposite side equal to, sorry, 2, which is twice as big as the adjacent side. So you can draw 10 centimeters over here and 5 centimeters over here. And there you'll have your right angle triangle. Now measure this angle over here.
Sir, is there a way to find the
Yes.
angle without drawing and using
Yes.
a protractor?
Yes. There is a way to do it without drawing the angles, without drawing the triangle. Okay. Because this you realize tan theta is equal to 2. This is not a standard angle, right? Can you take a guess though what it could be? Tan theta is equal to 1. Tan theta is 1. When is that?
When it's 45, when the angle is 40, when theta is equal to 45 degree.
Theta is equal to 45. What does that mean? It means that the opposite side and the adjacent side are equal when the angle is, opposite side is equal to the adjacent side means what? We have an isosceles triangle there, isn't it? So opposite side is equal to the adjacent side when the angle is 45 degrees. So when tan theta is equal to 1, we can say theta is equal to 45 degrees. But we have tan theta is equal to 2. Right? What's the next ratio that you know? What is tan 60?
Root 3.
Root 3, isn't it? So I can guess now. See, root 3. So, okay. When these two sides were equal, this angle was 45 degrees, isn't it? Now we are increasing the ratio a little bit. Root 3 is greater than 1, isn't it? So we are increasing the ratio again. So let's say this is root 3. This entire length is root 3 times this length. Okay, then the angle becomes 60 degrees. But if it is twice as big, the angle should be how much? Greater than 60 degrees, isn't it? The angle is greater than 60. Now I want you to try it out and see. I cannot give an answer to this because this is not a standard angle. But you asked me a question, can it be done? Can it be done without drawing it? Yes, it can be done. It's just that it goes beyond our scope here. Okay. So I want you to tell me the answer, but the way to tell the answer is to draw a certain triangle in your paper and to figure it out using the protractor. But when you use the protractor, you'll see that the angle is greater than 60 degrees. If you have a scientific calculator, you could do this. You just have to put tan inverse of 2. You'll get the answer. But that's a topic that we'll discuss later in the class. Okay.
$63.43490.
63.43 is it?
Yes, sir.
Yeah. Okay. How did you do it?
The calculator.
It's a calculator.
Okay. Should I have drawn it? and measure it. You'll get the same answer. Draw it and see. Any triangle, just make sure that the opposite side is twice as big as the adjacent side. Okay, anyway, now that we know the answer, it will come out to be 63 degrees. Okay, okay, I again forgot the second part there. Minus A minus B plus C. Or should I leave it as homework? Can you do that? Can you do the part B? Minus A. All you have to do is flip the sign of A. A means going 3 steps to the east and 4 steps to the north. Negative A means going 3 steps to the west and 3 steps to the south.
Sir, I tried it with the protractor. You get 63 degrees.
You're getting 63 degrees, right? Good. What side length did you choose?
3 and 6.
3 and 6. Okay, good. See, that also works. Fascinating objects, these triangles, isn't it? Yeah, so I'll leave the question, I'll upload the slides today. You go through them, okay? I'm leaving the second part there as homework for you. A particle undergoes the following consecutive displacements: 3.5 meters south, 8.2 northeast, 15 meter west. What is the resultant displacement? So there are 3 displacements over here: 3.5 meter to the south, 8.2 meter northeast, and 15 meter west. What is the resultant displacement? Can you write it as 4 displacement instead of 3? How, Sandra?
We are trying to find out the 4th displacement.
Not 4th displacement. There are 3 displacements given there, right? There are 3 displacements given: 3.5 meter to the south, 8.2 meter northeast, and 15 meter to the west. Can you look at it as 4 displacement instead of 3 displacements there? It's a vague question, I understand.
Sir, you could write it in terms of north and east.
Very good. Okay. You understood the vague question there. Okay. Very good, Afni. So you could write that 8.2 meter northeast as what? Some parts to the east and some parts to the north. Right? Would that be advantageous? Yes, because then you can look south as going down, then north there will be to cancel it out. East and west you can cancel some things out. It would be easy. So 8.2 meter northeast. Let me write that down. So 8.2 meter northeast. Okay, northeast means what would that angle be?
45 degree.
45 degrees.
45 degrees. This angle here would be 45 degrees northeast. Okay. So whatever distance that this person has walked along the east direction, it would be same as the distance walked along the north direction, isn't it? So this is 45 degrees. Can you find this eastward distance and the northward distance? So remember, in this triangle, what had happened?
So
In
8.2 divided by root 2.
Is it 8.2 divided by root 2? Let's see. So this is 1 root 2. Yeah, so 8 point, sorry, what did you say, Sandra?
8.2 divided by root 2.
Okay, yeah.
Yes, sir.
So this is 8.2. Okay, is everybody clear on that? Aishwarya, what is this? What is this length over here?
Which sir?
What is this length over here? This length?
8.20.
8 point, is it 8? No, it's not 8.20. This is 8.20. Look, that is 8.20. This should be slightly smaller than that, isn't it? I'm asking, how much is it?
I think 3.50.
How did you get it? 1 second. How did you get 3.50? 1 second. Can you explain me logic?
The less than 8.0.
Okay. No, it is not 3.5 something. No.
So isn't it supposed to be 8.20 divided by root 2?
Root 2. Yes, it's supposed to be that. Okay, so this is supposed to be 8.20 divided by root 2. Okay. And
Finally getting it.
yeah,
Sir, I have a doubt.
yes.
Sir, as it is a right angle triangle and one angle over there is 45, we can say even the other like other side is 45, right? So it'll be both the sides are 8.2 by
So
root
both the
2.
sides will be 8.2 by root 2.
Yes, both the sides will be 8.2 by root 2. Yes.
So how did you get the 45-degree over there? Sir?
45 degrees because they have told us 8.20 meter northeast. Northeast means exactly between north and east. 45 degrees.
Okay, yes, sir.
Aishwarya, are you sure about this answer? See, you get to ask unlimited questions, okay? Do not just sit quiet there. Is it clear, Aishwarya?
Okay.
So what I've done here is I want to figure out the hypotenuse, let's say opposite side. I want to figure out the opposite side. So I know which ratio to use now. Sine 45, sine of 45. What is 45? 45 is this angle over here. Sine 45 is equal to opposite side, the length of the opposite side divided by the length of the hypotenuse. Length of the hypotenuse is given 8.2 meter, isn't it? So opposite side, length of opposite side becomes equal to sine 45 into 8.20. So sine 45 is 1 by root 2 as we have seen before, isn't it? Into 8.20. This is what we've got. 8.20 divided by root 2. Right? The opposite, the adjacent side also will be the same. Or you can think like this. Okay, 8.20 meter is the hypotenuse. But this is a 45-degree triangle, meaning I have to look at this particular triangle first. Okay. So how much is the hypotenuse zoomed out by? How much is it zoomed out by? Can you figure out how much it is zoomed out by?
8.2 by root 2.
Exactly. So it has been zoomed out. Look at this. It was root 2 before. Now we have zoomed it out such that the length became 8.20, isn't it? So what is the factor of zooming? The factor of zooming is, okay, look at this. I'm starting with the root 2. I need to end up with 8.20, isn't it? So what is the factor that I need to zoom by? 8.20 divided by root 2, isn't it? So that root 2 and root 2 gets cancelled, you get 8.2 there. So if you want to go from root 2 to 8.20, then you have to zoom out by a factor of 8.20 divided by root 2, whatever that number is. Now, if you zoom the hypotenuse by 8.20 by root 2, you have to zoom other sides also by the same factor. See, 8.20 by root 2. And this side also will have to be zoomed by 8.20 divided by root 2. And then you'll end up with this triangle over here. That's why we get the sides as 8.20 divided by root 2. All right. Okay. Now something is clear. This 8.20 meter northeast, this vector I can write as 8.20 by root 2 eastward, E vector I'm writing. E vector means eastward vector plus 8.20 divided by root 2 northward. You can invent your notation like that. In the exams, we avoid this because there would otherwise be confusion. What is that E and N and all these things? So if you're writing it for yourself, you can invent your own notations.
Excuse me, sir.
Yes, Sarvesh.
So I'm not sure if this is right or no, but we have learned that the length of, like, for a triangle to be like a proper triangle, the length of one side should be lesser than the sum of the length of the other two sides, right?
Sum of the length, yeah, correct. Triangle.
But here it won't happen, sir, because 8.2 by root 2 plus 8.2 by root 2, I found out in calculator it's like approximately 3, but the other unit is 8.2, so.
No, it can't be, Sarvesh. I'm sure you're messed up. So, but thank you for bringing it up. Why am I sure you cannot be right? Because this is already given to you, isn't it? This is 8.20 given to you. This I'm saying it's 8.20 divided by root 2, and this I'm saying is 8.20 divided by root 2. Just apply the Pythagorean theorem, square this and square that and add them both. What do you get? 8.20 the whole square divided by 2 plus 8.20 the whole square divided by 2, which will come out to be what? Half of 8.20 plus half of 8.20 square. What does that come out to be? Full 8.20 the whole square. So square on the hypotenuse is equal to the sum of the squares on the other two sides. It agrees with the Pythagorean theorem, isn't it? So in case you are right, Sarvesh, then Pythagorean theorem has to be wrong. Okay, that's how I'm faithful. That's how I know that you cannot be right. But it's always good to check. So 8.20 divided by root 2. What does this come out to be? Five point something, is it? I'll have to bring the calculator to the class once again. Yeah, it's proper, no? It comes out to be 5.
Yes, sir. I instead of root, like dividing it by 2, like dividing it by root 2, I directly rooted 8.20. So that was.
Yeah, correct. So this comes out to be something 5.2 something, and this comes out to be 5 point around that. So you can see the sum of two sides. You take any two sides. Okay, you can take these two sides here. Take these two sides. Sum of these two sides is 5.2 plus 5.2, that is 10.4. Actually, it's greater than that. I did not see the answer properly in the calculator. So this is 10.4. So the sum of the two sides of a triangle are greater than the third. Works out. You take this sum now, look at that. You take any two sides. So any two sides can be taken. So let's take these two sides. 8.2 plus 5.2 is definitely greater than.
Sure.
Yes. Yes, that's it.
How did you get the 5.2?
I used the mobile phone over here. 8.20 divided by root 2. Okay, it's not 5.2, it is 5 point something. But it's okay, it doesn't matter.
Estimation, okay.
Yeah. It's 5.81, sorry. 5.81 it is. Anyway. So let's complete the problem. So we have written the, what do you say, 3 vectors that were given to us, 4 vectors. So we have 3.5 meter to the south, but south I'll write as negative north. Mathematics, right? South is negative south, south is negative north. Plus 8.2 meter northeast, that is nothing but 8.20 eastward, sorry, 8.20 divided by root 2 eastward, plus 8.20 divided by root 2 northwards. And 15 meters to the west. But west for us is 15 meter negative east. So these are the vectors. Now you can add east and east, north and north. So the resultant displacement is 8.20 divided by root 2 minus 15 eastward plus 8.20 divided by root 2 minus 3.5 northwards. And that's your answer. Yes, last question for today. And then we'll go home. Okay, I'll go home. 3 vectors are oriented as shown in the figure below. Where, okay, look at that symbol. A vector under in between 2 lines, that means length. Okay, so the length of the A vector is 20 units. Whatever these units are, feet, inches, doesn't matter. Length of B vector is 40 units and length of C vector is 30 units. Find the x and y components of the resultant vector expressed in unit vector notation and the magnitude and direction of the resultant vector. So first you find the x and y components of the resultant vector and the magnitude and direction of the resultant vector. This is for you guys. See, mathematics is like a game of chess. So that's what I was doing right now. Like even I've not solved this problem before. Right? So I'm thinking like, what can I do? So I tried out a few possibilities in my head.
Now I know I am bad at chess.
Okay. I wish I could say it's like Ludo, but it's not. It requires strategies. So do not go according to whatever I've taught before. There is a nicer way to do this problem. Don't be like a robot, like, okay, I'm going to find the components and do that. That will work. It will definitely work. It's not a wrong thing. Because I just noticed that magnitude of B and C. Look at that, 4 and 3, 40 and 30. Angles of 45 and 45. Add them to 90 degrees. What's going to happen?
So I found out the x and y components of the resultant vector, but I'm not sure if it's right.
Okay, let's see. What did you find? What is it? What are the x and y components of B vector?
No, I took it like we're supposed to find the resultant, right?
Yeah, we're supposed to find the resultant.
So I think it's 20 plus root 450 I cap. I'm sorry, sorry, 1 minute.
Their resultant means you have to add A, B, and C, right? Does it matter if I add B and C first and then A? Commutative property, isn't it? We can add any way we want. So if I add B and C, okay, how to add B and C? A triangular law. So I have to move the vector C without changing its direction to the head of the vector B.
Should I send the answer?
Oh my god, okay, that's quite deep.
I didn't simplify any like the roots or anything.
Yeah, that's okay, that's okay. So I'm writing the vector C. Is everybody in agreement with that? We can do that, right? So this C vector is no longer here, it has been moved to that place. What is the resultant of these two vectors now? This vector. Does that help in any way? What is the size of this vector? This is 30, right? And this is 40. So this would be 50. 3, 4, 5 triangle, isn't it? 30, 40, 50. But does it help? I don't think so.
So I just directly took like I ignored the B part. I
Yeah.
just like added A and C. Like that's the displacement, right?
A and sorry, I did not understand what you said.
I think I went wrong.
It's okay. Can we resolve the B vector into two components? Sorry, you can't see this color. I'm resolving B vector into two components. What are these components equal to? It's 45 degrees. B value we know 40. The length of the B value B vector is 40. So what are each of these components equal to? Yes, 40 by root 2 and 40 by root 2. Can we resolve C in the similar fashion? Resolve C. Again, this is 45 degrees. So when I resolve C, right, when I resolve C, I get 30 by root 2 and X component is 30 by root 2. Is everybody fine with this? And then you have the A vector, which is given to be 20 units. Okay. Now, how to find the resultant? Look at that. Resultant.
Addition of all these three.
Yeah, addition of X and X components only. You cannot add X components to Y components, isn't it? So
Yes,
add
sir.
X components to X components. What are the total X components that we see over here? Result.
0, 40 by root 2 and 30 by root 2.
Yeah. A vector has 0x component, 0x component, plus the B vector has 40 by root 2 x component, and C vector has 30 by root 2 as the x component. So this is the x component. Plus is vector addition here. Plus, what are the total y components?
20, 40 by root 2 and minus 30 by root 2.
20 plus 40 by root 2 minus 30 by root 2. And this is along the y direction. Now you can certainly simplify this. 40 by root 2 plus 30 by root 2 plus 0 by root 2. Right? How much is that? That is 70 by root 2 I cap plus 40 by root 2 minus 30 by root 2. Sorry. That is 10 by root 2. And we have 20 plus 10 by root 2. j cap. And this is your answer. Done. Okay. Again, part B is for you to think about. Next class will be solving the workbook problems that you have. If you can solve these, that should be a piece of cake.